Hello, everyone. My name is Asaf, and I'm a data scientist here at Joytunes. So today we'll be speaking a little bit about how we utilize gradient boosting regression in order to enhance our user acquisition work. Oh, I have this. So today we'll be speaking a little bit about Joytunes. Then I will show you why we chose to invest in such a model, invest the time and effort. Afterwards, I will present the solution, which not so surprisingly includes gradient boosting. And I'll show you the data model and the main things we had to overcome in order to achieve good enough results, so our campaign managers will be able to use it as we want. I will show you, and later on I will show you how we use it in production. Okay, so our main goal here at Joytunes is to connect people to their more creative side and let them learn how to play musical instrument by themselves, which is super cool. Our vision is to become the standard in this subject. We currently have 3 apps, all of them focused in piano learning. And as Mike just said, we're now developing an app for guitar. And stay tuned, there will be more. Okay, and today our main growth engine is Simply Piano. So Simply helps users learn piano by themselves. We have a recognition engine that helps recognize the notes and the chords that the user play, even in noisy environments. I'm reminded you that people use the app at their own homes. So Simply really succeeded, and we now have hundreds of thousands of subscribers that can play piano to some extent. The app uses a subscription model. Our most common offering is a yearly plan with 7 days of free trial. This is what most of our users choose. We have also 3 or 6 months plan and the yearly plan with no trial that users obviously can't enjoy the free trial like the first offering. We have really high reviews in both iOS and Android, and basically people really like our product. As I told you, I'm positioned in the acquisition team. Our team combined of multidisciplinary people. We have growth people, we have developers, user acquisition managers, and we have me, a data scientist. And our team have a main goal. Our main goal is to educate potential users about Simply Piano and encourage them to subscribe to our service. And we want to grow as much as we can. We want to grow very fast, but we want to maintain a certain performance to our campaigns. So we follow 2 main KPIs. The first KPI is the customer acquisition cost. Customer acquisition cost is basically the media cost. Media cost is what we pay Google, Facebook, any place that we publish our ads. This is why we pay them for showing our ads, and we divide it by the amount of subscribers, which basically give us the average amount that we pay for each subscriber. The other part of the equation is the lifetime value. Lifetime value is what we expect to get from a group of users. And we basically calculate it by averaging renewal rates of our previous plans. And this number is relatively stable. But the customer acquisition cost, as I will show you, varies a lot between the campaigns. So in simple words, we want to grow as much as we can while maintaining a positive ROI. So let me tell you a little bit about our acquisition work, or where do subscribers come from. It's not easy, but they do come. So we publish our ads on many different media sources, such as Facebook, Instagram, Google, YouTube. Each of them also have a different behavior, which I will show later. So the flow of potential users, see one of our ads on a specific platform, you click on the ad, he will be redirected to the application store, and you all know where it's going from here. You will install the app, open it, and hopefully enter the free trial. And after this, if he decided that this is what he wants, he will subscribe. We also need to keep in mind something very important, that almost 50% from our entire subscribers are not attributed to any media source. They are not attributed to a specific campaign and not attributed to Google, Facebook, etc. And why is that? So two main reasons. First, some of the users want to learn piano, so they research by themselves, and then they obviously came to the right conclusion that simply piano is the best option for them. The second reason is that some of the users who see our ads will not click on the ad. And since we use click attribution in order to connect a user to a campaign, we will not know from which source he came from. So remember this. OK, after we know all this, any question about JoyTunes, about our team? Amazing. So, assuming that we have 2 campaigns.
I have a question. Why did you start with piano?
Excuse me?
Why did you start with piano?
This is way off topic. Let's discuss later. Piano is cool. This is why. OK, so assuming 2 campaigns, and now I'm thinking about your question. It's a good question. So let's assume 2 campaigns, campaign A and campaign B. And as I told you, we have a subscription plan. So first day after the install, we can see subscribers who subscribe to one of the immediate plans. They subscribe to the 3-month plan or the yearly plan with reduced price. And after 7 days, we can see the first users who graduate from trial. And as I told you, this is the vast majority of our users. So this creates a certain challenge that I will just show you. So let's assume those numbers, they are obviously made up. And by those numbers, if we want to judge the performance of the campaign a day after install date, meaning a campaign that performed yesterday, and we want to judge the performance today, we can reach to the conclusion that the customer acquisition cost of campaign A is $40 US. The customer acquisition cost of campaign B is $44. And I'm reminding you, lower CAC mean better performance because it's the average cost of the asset. If we decided to judge our performance based on this and just this alone, we might have increased the budget for campaign A. We might close campaign B if it's not profitable as we want. And this is what we have done. But if we judge the same campaign on the same date, we would have gotten a completely different result. And why is that? It's because of the 7 days free trial. And I reminded you that unlike the numbers here, most of our subscribers chose this plan. So here we would maybe increase the budget for campaign B or Z, but what's the main deal here is that we would have made the wrong choice if we would just judge a campaign a day after the install. However, if we will wait 7 days, we will lose a lot of money because the campaign will be running on the days after, and we would have came to the conclusion really, really late. And even more than this, like any app, we have an issue of late conversions, meaning that users who download the app on a specific date and didn't even open it on the first date. I'm sure that most of you can relate to this. Download the app, forget about it, reminded that you download the app, start using it. So meaning that the performance of a campaign, the subscribers that came for a campaign in a specific date, can keep accumulate for 1 month, 2 months, 3 months into the future, which create a certain issue because we don't know when we can judge the performance of the campaign exactly. So ideally, we would like to know the amount of subscribers from a specific campaign as soon as we can, meaning between the window of the first day after the install, because we won't judge the performance of a campaign on the same date, and the 7 days after the install, where most of our subscribers join our service. So just to summarize the motivation, trial blindness, we don't know who will subscribe within the trial period, and the issue of late conversion, which we just discussed. Reaction time. We want to react as fast as we can. So if we react fast enough to a good performing campaign, we can exploit the potential. We can increase the budget. We can duplicate the campaign. We can do a lot of things in order to exploit the potential. That was scary. The second thing is so early reaction to good campaign and early closing of bad campaigns. We can also use it to detect issues within our app. So if we just release the new version of our app, and certainly and immediately the prediction that this is the solution that I will present will show weird numbers, we will know that there was an issue with the version of the app. The third is analytics. So a model like this will save a lot of time. And why is that? Because we use a lot of inputs in order to generate a prediction. And the outcome is exactly what we need. It's exactly how we want to judge our performance. So it saves a lot of time to our talented campaign managers. And it also helps us to allocate budget between two marketing entities. So if we will have this prediction, we could aggregate it to the media source level, meaning to all the campaign under Google. We could aggregate to Google and then judge, for example, Google performance vs Facebook performance. So this is the motivation. Any questions so far?
Don't you factor in the number of users? Because you can have a lower CAC, but you only get 10 users in the trial, and higher CAC, but 10,000 new users. So I would still choose the 10,000 users, even though for each user I pay a bit more, because in the long run.
That's a great question. We actually do it by assessing. You will see it in a few other slides. What we're predicting exactly is the amount of subscribers, because the media cost is fixed. So stay tuned. Yes?
You do only like show A/B testing, or you do like a fraction of the campaign and test the feature of the campaign, so only A/B testing?
I did not understand you, sorry.
There's also, apart from A/B testing, there's also fraction factory analysis, where you check feature of the campaign and compare it, and not just A/B testing. So you do only comparing one campaign to other, or also?
No. Okay, I understand you. You will also see this in the next slides, but this prediction can be aggregated to any level we want. So we can judge any marketing entities using this model.
About the issue detection, early issue detection. It's not clear. If we use a prediction model, it probably should expect that we have all things normal. So how we can actually detect anything? So it's unclear.
Okay, so what I'm trying to say is that if we see that the prediction, when we aggregate it on our entire activity, goes up in a certain date, it means that something has happened, and it actually did happen to us before, that there was an issue with one of the marketing platforms, and we did detect it by using the prediction. Thank you for your questions.
Don't you check churn rate?
Excuse me?
Churn rate.
It's not related to this prediction. It's related to other part of the company, which I'm not part of at the moment. Okay, amazing. So surprisingly, the solution is to predict the customer acquisition cost 90 days after the install. And what do I mean? I mean that if we want to check a specific date, and we want to understand the final results of the campaign. So the final results of the campaign will be 90 days, and I will show you why in a second. And as one of you asked, we don't really have to predict the customer acquisition cost. Since the media cost is fixed for a certain date, it will not accumulate like as I just showed you. All we need to do is predict the amount of subscribers from a certain campaign on a certain date, which makes the life a lot easier, and also we can use the prediction for another use cases. So we will predict the amount of subscribers 90 days from install date by the first 3 days. Why do I mean first 3 days? And this means that we will there was a specific date, and then we will gather data about the users who installed the campaign from a specific campaign on a specific date, and afterwards we will predict for the next 87 days what will be the number of subscribers. So now I have to answer 2 very important questions. The first is why 90 days? So as we all know, our training set need to be greater or equal to 90 days ago for each test we want to do, because we can't predict while the results, the target has not finished accumulates. So we looked for the shortest amount of time that we can get a good enough estimation for the final results of the campaign. And over 95% from subscribers crossed between a campaign and a date will subscribe in the first 90 days to the install date. So this is really good enough estimation. So I'm reminded that our app constantly evolves. We add new features. We improve the experience of our users. So the app a year ago is not like the app today. So we had to take the shortest amount of time that represent our final campaign performance from a certain date.
By the way, if the application is evolving, how come the model is stable? It should be evolution also in the model itself.
Of course. So we generate a prediction for each date for a certain time range. I will touch on this method. I will explain on this method. So the next thing that I need to answer is why 3 days? So this is really easy. This is the first date that generate good enough performance on the first iterations of the model. I will later on show you what will be our next steps to generate the model, and you will see how we will overcome this. So why XGBoost? This is the main reason we're here. So it saves a lot of time. Comparing to linear model, you don't need to tamper with the data a lot. You don't need to care too much about feature scaling. You don't need to care too much about multicollinearity. And the second thing is the fact that it's not linear. It's based on decision trees. As some of us know, decision trees tend to overfit a lot. So because of the fact that XGBoost is an ensemble method, which combines the performance of many weak learners, it makes him very robust to outliers and robust to overfitting. And also, and most important, it beated any other model I tested. So as we can see here, the linear estimators performed the worst or didn't perform. And the best and the ensemble tree-based models performed much better. And the one that performed the best on many different iterations I made was XGBoost. So if linear regression is a Toyota Corolla, gradient boosting is a Blackhawk. It's made me laugh way more than I should. OK, so the solution was to create a data set so it will be able to represent very well what we want to predict. And we use 4 different sources. First of all, a little zip. Great. So from the platform meaning iOS or Android, we take the purchase information of the user who purchased on the first 3 days. And the second media source is the mobile measurement partner. So mobile measurement partner basically creates the connection between a specific campaign to a specific user. This is the reason that we know that a user ABC came from campaign 1, 2, 3. And we basically take device information, which is super crucial for creating this model. We can know the device country. We can know if it's a high-end device or a low-end device, which also indicates a lot. And we can know if it's a tablet or a smartphone. You can guess which one subscribes more. There are the media sources, the sales data sources, the media sources. And from there, we basically take the media spend, the link clicks, the user who clicked on the ad. Maybe I clicked but did not install, but it does indicate about what the users from this campaign will do. And the last part is the last but not least is simply piano events. So as I told you, one of the most important features of the model are user who enter trial. And we take it from our event. We also take a certain aspect of app location, how many levels a user finished, what levels. We also, because of our recognition engine, we have indication if our users do have piano at home or don't, which also really important. And certain page views, such as a payment page or any other important points in the user journey inside our app. So we combine all and store it in our data warehouse, and then we create the data set, which will be the training set, where each row represents the crossing between a date and a certain campaign. Reminding each row is the crossing between a certain date to a certain campaign. So, as I told you before, 50% from our traffic are unattributed. So if you will try to imagine how it looks in the training set, it will be like one huge bulk of 50% of our data, which is not useful. We can do better if we want to perform make our model perform better. So what we did here and is called unattributed traffic, like the rest of the media sources, meaning that we have Facebook, we have Google, and now we also have organic. And the second thing was to sub-segment the unattributed traffic to campaign-like entities. So we just make the crossing between a campaign and a country. Platform and country. So meaning that we have a campaign A, campaign B, campaign C, and we also have iOS United States, iOS Android, United Kingdom iOS, United Kingdom Android. This actually increased the data amount, the training set per 1 day by 2 times, meaning that obviously it's not surprising because it's 50% of our traffic. And it's actually helped to improve the performance of the model by 30%, meaning reduce the mean square error. You confused me a little bit. The mean square error by 30%. And one other thing we had to do in order to improve our model is something that is very not Kaggle-ish. In Kaggle, you get data, maybe not so clean, maybe you need to tamper with it a little bit, but you don't have the question of how much data to take most of the time in Kaggle. So reminding, our aggregation is at a campaign and date level, and the question and we also know that our data set is bounded for any specific date we want to predict minus 90 days. Why? We want to predict 90 days in the future. So the question was between what to bound it. So 90 days, any date minus 90 date, and so as you can see, because of the scale here, we have a trade-off. The trade-off is between the relevance of the data and the amount of the data. So consider that we have one bound of current date minus 90 day. And if we want to get the maximum amount of data, we will take our lifetime value. But a large part of this training set will not be relevant. Why? The app evolves over time, and we need to make sure that our model evolves with our app. To systematically test different periods, meaning between 90 days and check it on different time of the life cycle of our app. Why? To make sure that it's prone to the model improvements, which I guess this is what you asked. Amazing. So, mean absolute error. I put it especially for you. And as we can see here, there are a few data frames. Here is T. T is a date that we want to predict minus 90, 30 days of data, 60 days of data, 90 days of data, 275 days of data. I checked it for every 30 days. So what we can see here is very interesting because unintuitively, the largest amount of data did not perform the best. And this is what we think as a data scientist, right? More data is always better, but it's not always better. More relevant data is always better. So also, mean square error, we can see that the minimal point was 90 days. I thought that it's really nice that in order to predict 90 days into the future, we need to use 90 days. So every single time, for every iteration I checked, 90 days data frame performed the best in terms of both MSE and MAE, mean absolute error and mean square error. Just a second. Questions?
The 0 day, did you change it? Did you try different 0 day? Or you had, because maybe you just catch trend for the last 90 days?
Okay, so we basically generate the prediction with each day passing. So for each day, we take the current date minus 90 days on one end, and on the other end, the current date minus 180.
Trend over a year or something like that? Like seasonal trends?
Yes, exactly. So this is what I mean to check it on different times in the app lifecycle. So what you're asking is very, very, it's a great question because if 90 days works the best now, it doesn't say anything about if it worked the best in the future. So we did have to test it on different periods on our app. Thank you. So any other question? Shalom.
How do you, I assume that you release a new application every time. So how do you take out the impact? I assume that you want to check only the campaign influence. So how do you take out the changes in the application and new features from this?
So this model is designated just for Simply Piano. And since it's our main growth engine at the moment, it's really, really reasonable to invest the time in creating such a model. Amazing. So, results. So, as you can see here, this is very satisfying for a data scientist to see this kind of behavior. So, the model generalized very, very well the problem that we want. We can see that the mean square, of course, it's in subscribers, yes, is very low, but low, it's need to be in relation to something. So what's more important and what's the main point here is that the model was good enough to our users who needed to use it, meaning it has a really big business value. And next, I want to show you how we use it in production. So how our campaign managers use it. So it's basically here to serve them and save them a lot of time and enhance their work. So we implemented the predicted score in our reporting system. We use Tableau, which I'm a big fan of. So it's usable in any aggregation level, which was also one question here. So we can judge campaigns versus campaign from a same marketing platform. We can judge different media sources, and even when we have new media source, we can early judge the performance of it. Also, we constantly make tests. We have new ad creatives that our talented creative team makes, and we want to test how it performs. So we can spend way less money when we test them comparing to what we had before we had the model. And we use it to overall optimize our activity. And the two charts here are predicted against results of two different media sources. The first is Facebook. The second is Apple Search Ads. And it's aggregated for a certain amount of time. And as we can see, the model worked really well in production. So we're super happy about this. So our next steps is to create an updating version of the model. So all what we discussed until now is M3. What is M3? M3 is the model designated for create a prediction 3 days after the install date. And as we all know, we enjoy information gain with each day passed. So on the 5th day, we have much more information about our users from a certain campaign on a certain date than the 4th day and then the 3rd date. But we do want to give a good estimation as soon as we can. So the trick here is to create 7 different models, which is after you created the first one is not so difficult. And because you already made all the research you need and understand what should work, what should not work, the training set is relatively the same, just bounded by 1 day and not 2 days, etc. And the main idea is to update each day with each information gain until the 7th day where we can see the first users graduate from trial. Okay, so before the question, there is no meetup without our open positions. So this is our open positions. I think that the most relevant position that we have is the music information data scientist, which is basically to help us enhance our recognition engine, as we just discussed. And now, okay, questions?
So the lifetime value, it's not depending on the source of the query. So how you did you understand? Because in my experience, it's usually depending a lot on the source.
Do you talk about the lifetime value?
So you said that you assume that a lifetime value is the same, and you have this some information for your app. So how you can understand that the lifetime value is the same or not?
Okay, this is a great question. For the terms of this talk alone, I did not enter the lifetime value at all, and just show you the customer acquisition cost prediction. We can talk about it. I will just say that we can make further work in order to make it much more accurate than we do today, but one step at a time. Anything else?
User customer and predicted according to the amount of data that you have on it, like splitted the customers?
No, one line in the model is the costing between a campaign and it's not a user-based model.
Okay, it's campaign.
Yes.
So I have one question connected to the previous. So you said that you're using the data about users.
The what?
About the user parameters when predicting on the campaign level for campaigns,
yes.
Right? So how you aggregate this information?
I'm sorry, I didn't quite get you.
You said you use the user-related features in the campaign-based models.
Yes.
How do you?
Okay, so I just made an aggregation to the date level, and obviously we can attribute the campaign to via the mobile measurement partner, and I combined it, I made an aggregation and added to the data set.
Okay.
Good question, however. Thank you very much.